Hey, what's up everyone? Today I'm going to be talking about the Mitsubishi Hyper Heat system that I had installed in my new addition for heating and cooling this upstairs room. Now this is about 800 square feet. I'm going to show you guys here the system that I went with, how it's been working out for me, what it's cost me on average in the past 35 days or so to run it, and how much electricity this has been basically using over that amount of time. Now this isn't going to be a super detailed video about numbers and what it's going to cost to run and everything like that, but I am going to go over one of the main things that drives me insane about this thing, and that is going to be the phantom power draw. Now this unit is supposed to be super high efficient and is supposed to draw a minimum amount of power and regulate that power based on the needs of heating or cooling you need. And I mean, it is pretty efficient overall, but I'm going to be talking about exactly how many watts this thing draws even when the thermostat is off. As long as your breaker is on and the unit is getting power, whether the thermostat's off or not, this thing is drawing an amount of energy which has me going nuts wondering if there's something wrong with the unit or if this is normal. So I would appreciate it if you guys have one of these or have any experience installing these or any knowledge about the system. If you can comment below and let me know if this is normal for the power draw on these things, the phantom power draw, or if this is something that maybe I should get looked at. Maybe there's something staying on, like a block heater or a pan heater or something like that, that's not kicking off when the temperatures get warm. One thing guys, before we get started, if you can help me out by hitting that thumbs up if you guys like this video, and please consider subscribing so you guys can see more content like this. It really helps my channel grow and it helps me out with the YouTube algorithm, so I just want to thank you guys. Let's go ahead and get into it. So basically, when I had this system installed, I had different bids from about 4 or 5 different contractors, heating contractors, about what I should do to heat and cool this upstairs room, which is about 800 square feet. I've had prices anywhere from like $12,500 all the way up to $20,000. One guy told me that I needed a separate heating system for downstairs and a separate furnace for up here. I would have had to box off a little room, put a separate furnace in for up here, and that would have been the best way to do that. And then I've also had a guy tell me that he was just going to run everything off the new furnace that was installed in the basement for the downstairs. He was going to run ductwork up through here and put the ducts supplying the air up here in the ceiling, which I didn't want to do because figured I would have lost a lot of heat and cool efficiency up through the roof there, and with the ductwork being inside the attic, which gets really hot in the summertime and cold in the winter. So I didn't want to lose any of that efficiency. One guy told me that if I did go with a mini split system, that I would need a unit on this wall, basically a double unit, which you could run multiple heads off of one outdoor condenser. And he told me I would have had to put one down there. That way it would heat and cool this whole space evenly. He said one unit would never do it. And then I had another guy tell me that no, one unit is fine, just go with a little bit bigger unit and I wouldn't have any problems. So basically what I decided to go with was the third guy that told me that one unit would do it. I figured I'd go ahead and give it a try. And the reason why, the heck is that noise? Now the reason I decided to go with the Mitsubishi Hyper Heat system is that because here in Pennsylvania it does get down to pretty cold temperatures in the winter time. Even though we've had a pretty mild winter this year, this thing will heat all the way down to negative 13 degrees at around a 73% of the heat rating that it says it will heat down to, which is about 20,300 BTUs. So it'll go 73% of that down to negative 13 degrees, and it'll heat 100% of that down to 5 degrees. A regular mini split or heat pump will only heat down to about 23 degrees, and then below that you lose a super amount of efficiency or it just won't produce heat at all. So I was a little bit concerned about this room being able to be heated in the wintertime. Now the heating guy that told me that one unit would work told me that a lot of the heat from downstairs from the furnace would rise up through the floor and keep this pretty warm up here, and that would basically contribute to heat if I needed a little bit more. And he was absolutely right. I mean, I could keep that thing completely shut off, which I've done just to see, and it does stay within 5 degrees of my downstairs temperature. Now my furnace downstairs may run a little bit more because maybe more of the heat will rise, I don't know, but I didn't see a problem with even not running this thing and it just staying pretty warm up here. Now with that being said, I'm glad I did go with this system. I mean, it does supplement up here the heating very well. I didn't have to run extra ductwork or anything like that. Now I did install 3 ceiling fans up here just to keep the air moving. That way, I haven't really needed to use them, but I do have them if I need them to get the air circulating around all up here. just so that it could get from one end to the other, which is about 40 feet. Now these systems, they're supposed to be super high efficiency and supposed to just use the power that they need based on what your current situation is and what the temperature difference is that it has to bring up. Now it does regulate that difference. I mean, I could see it in my wattage of how many watts it's drawing based on the temperature and how high or low this thing has to ramp up or, you know, heat or cool your area. And we're going to go ahead into my Smart Things app, which is my home automation app. I have a energy meter hooked up to this thing, so it'll show you guys basically how much it cost me to use over the past 35 days or so. It'll show you guys exactly how many watts this thing is drawing when the unit's not in use at all. So let's go ahead and I'll show you guys here. Basically, this is my home automation system. Right here you can see my mini split is drawing right now. The thermostat is on, but it's still drawing 204 watts. Now, here's the additional thermostat that I have hooked up to it. Now, this is a MHK1 thermostat, which is able to hook to my wireless redlink system, and then I'm able to go on the internet and control the different temperatures. Now, basically, I put that thing on here. It does not come with that, which is a little transmitter here that connects the thermostat to this, and then this sends the signal down to the redlink hub, and then you're able to connect to it and control your system on the internet. Now that thing was a few $100s, which is crazy because it really, I mean, it works, but the whole Honeywell system thing online, I mean, you can go on and control your temperatures, but usually they send you a report every month about how much heating or cooling your system has, like how many hours it's heated, how many hours it's cooled, and compare it to last year. For some reason, my other two thermostats for my two furnaces in my existing part of the house, it tells me that report every month, but for some reason, it never gives me a report on this, even though it's through the same app, through the same system. I don't know why it doesn't give me a heating or cooling diagram on that. Maybe that's a fault in their system, but for the amount of money that I spent on that thermostat, I would love for it to be able to tell me those things. So now you can see here that it's drawing 208 watts. Now I reset this thing on February 2nd, 2020, which you could see right here. You could see that from then until now, which is March 7th, up here in the left-hand corner, it's March 7th now. So that was basically about 36 days. And it took 302.607 kilowatt hours to run this unit the past 36 days. Now, the average temperature here in Pennsylvania has been 32 degrees for the month of February with a high of 43 and a low of 22. Now those are just average temperatures. I've had this thermostat basically set on 66 the whole time. You can see it's 68 up here right now. But this unit does come originally with this remote right here that you can control a lot of different things. The only thing I don't like about this is there's nothing that tells you your current temperature. This 66 is what you currently have the unit set to. And that's another reason why I purchased this external thermostat, so that you can actually see what the temperature is up here. All right guys, one other thing I wanted to show you about these remotes that drive me nuts. Now this is the remote that comes with it from the factory. This remote does not communicate both ways to the unit on the wall. You have to have this remote pointed directly at the unit, and you have to hear the unit beep when you adjust it for this thing to work. Now, if you purchase this additional one to allow you to hook up to the redlink system and control it over the internet. Now, there are two other systems I believe that you can do this with, and that I think is the Kumo Cloud, and I think there's another system that you can hook. Well, I already had the redlink system for my modulating furnace downstairs, so I went ahead with this one. That way it would be able to integrate with that. Back to what I was saying, if you do purchase this unit, you can mount this anywhere and it will actually base your temperature reading off of this unit itself, off the thermostat in this handheld unit. If you do not purchase this and you use just the remote, the temperature actually is based off wherever the unit is mounted. So there's a temperature sensor in there, and that will regulate your temperature of the upstairs room. Now I wanted this one, that way I can mount this down here on this wall here, and it would actually sense the temperature all the way down here and keep this whole upstairs room nice temperature wise. Now with that being said, you could still use this remote to control the unit when this is hooked up. The only downfall is if you adjust your temperature on this unit, you'll see that I can adjust it up, say to 73 degrees. Nothing will ever change on here because it doesn't communicate back to this to tell it. Now, if I change it on here, as long as I'm pointing it at the head unit, I could change it back down to, say, 70, 71. Now, it will communicate back to this, and this will automatically go back down to 71. It does take a minute or so. There it goes. So you could see there, if you adjust your temperature with this here, it will communicate back to this and change it. But if you adjust your temperature with this, the unit does not communicate with this to change it on here. So your readings could be off. If you adjusted it with this, your readings on the two could be off. This one could say it's set at, say, 69, and this one could say it's set at 72, or vice versa. So that's another thing that drives me a little bit nuts about this system, being that it costs so much money. Basically, like I said, you could see for the past 36 days, it cost me $33.29 to run this, which is about 93 cents a day. Now that's not too bad, considering the average temperature has stayed about 67 degrees up here, which is pretty warm because I have an R38 in the knee walls, and in the walls going up on an angle, I have an R50 in the ceiling, and then an R19 in the side walls and in the dormer walls. So it's insulated pretty good up here. I made sure to insulate really well when I built it. All right guys, so now I'm gonna go ahead back into the SmartThings app. I'm gonna go ahead and crank this system up a little bit. Let's crank it up to 69, just to show you guys, once this thing kicks on, the kind of watts that this thing is gonna draw. All right guys, now you can see that it's drawing 790.8 watts currently right now. Now the unit is still really not kicking yet. I mean, you could feel a little bit of the heat, but the fan motors did not kick up yet to blow the heat out. Now, one thing I do want to mention about this thing, when you're in heating mode, the fan spins constantly. It never shuts off. It does spin at a very slow speed constantly, just to keep the air circulating just a little bit, which I'm sure is drawing some power, but definitely not 200 watts. I mean, this thing runs off of DC. It's converted to DC. Now, I don't know if some of the power draw on this thing is because of the DC conversion. All right, now you can see that it ramped up to 833 watts. All right, now it's starting to blow heat here. You can see I have it set so this side vane moves up and down, and I have this one set up all the way just so that it will shoot the heat out over that. Now it's starting to blow heat here, and it's actually blowing pretty good. So let's go ahead and see what kind of wattage it's drawing now. So right now it's still drawing 833 watts. Let's crank it up a few degrees, 3 degrees higher than what the temperature is in here. And now I have it set to 71, and we'll see what the wattage on this thing goes up to once it senses that it needs to pick up extra 3 degrees. What we're gonna do here now is we're gonna take this remote and we're gonna kick it on powerful, and what that's gonna do is basically put it in like a superheating mode to bring the temperature up into the room quickly. And I don't know if you guys heard that, but the unit beeped, and eventually this power rating is gonna go way up now because it's set to powerful, and it's gonna give it the max that it can give it to bring the temperature up super quickly. Now you can see that it's drawing 1,512.7 watts, and that's because I have it kicked up on powerful mode to bring the temperature up in the room quickly. Now let's just take a quick shot of this. .95 temperature coming out of there. And you can see the wall 62, 95, and 68 up there. So yeah, it's saying it's about 92 to 95 degree temperature coming out of there. And yeah, it's pretty warm. Definitely pretty warm. So 63. Now this thing has never really been 100% accurate, but it's within a few degrees, I'm sure. So 62 degrees there. 60 degree down this end. And 61 degree down this end. So there's a 1 degree temperature difference from one end to the other. Now, like I said, this is not exactly accurate. It may read a little less because obviously the temperature up here is like 69 degrees right now. But that will give you a rough idea. So this actually might be putting out a little bit more, a little bit higher than 95 degree temperature, because I believe this thing is reading a little bit less accurate than what it should be. All right, guys, so now I'm going to shut the thermostat off and show you the power draw with the thermostat off. Then I'm going to go down in the breaker box, kick the main breaker, and show you guys that that power goes down to 0 watts. So there's definitely a power draw on this thing constantly, no matter what. I'm going to shut the thermostat off here. You can see it's off. We're going to give it a minute, and then we're going to wait and see if this goes down at all. Now let's go down into my basement, and I'm going to shut the breaker off, and then we'll see if this goes off at that point. All right, guys, so now I'm down at my breaker box, and you can see it's still drawing 204 watts. I'm going to go ahead and shut the breaker off and see how long it takes. You can see already it went down to 3.1 watts, and then that should actually go down to 0 here in a second. So basically my energy meter, which is right here, this hooks up to the two leads of the 220 volt breaker here inside the panel, and it monitors the wattage going through that. The breaker is off, and it is not drawing pretty much any energy now. Normally that says 0. I don't know why it says 3.1 right now, but normally that would be 0 watts. Now I'm going to go ahead and turn it back on, and we will see 208.3 watts. So you can see the wattage that this thing is drawing when the breaker's on, when the breaker's off, and why I believe there's a phantom power draw on it. And like I said, when I shut this breaker off and turned it back on, the thermostat was actually off, so it shouldn't have been drawing any power or a minimal amount. All right, guys, so now I'm just going to go out and show you the condenser unit that's outside, and basically talk a little bit about the power draw and what it's costing me for that. Now, basically the system draws 200 watts nonstop constantly. I pay about 11 cents per kilowatt hour when you factor in all the fees and everything for my electricity. So basically that equates to about 53 cents a day, no matter if this thing's on, running or not, which over the course of those 36 days would have been right around $19.30, even if I would have had the thermostat off but the breaker on. And to me, that's a lot of money for not using any of the electricity of this thing, just sitting there idle. And here's the outdoor unit here. It's a Mitsubishi electric H2i unit, and the model number is MUZFH18NA2. And basically to have everything that I had installed, which is a furnace in the bottom half of my addition, a modulating furnace, 2 air units, which you can see right here, one for my existing part of my house, the new air unit for the addition, and then I also got this Mitsubishi mini split system installed for just heating and cooling the upstairs. And for all that, it was $14,500. So like I said in the initial beginning of this video, I said I had estimates from $12,500 all the way up to $20,000. I selected the $12,500 option, and I could have got that price down a lot, but I wanted to go with the modulating furnace for more comfort. And if you guys don't know what that is, it actually uses more or less gas, and the blower speed blows higher or slower depending on how much heat it's calling for. And it's supposed to be a lot more efficient, but mostly more comfortable. And I could tell you guys that my experience over these past 2 years of having it, that the modulating furnace, whatever I set the temperature to, it does not fluctuate at all. It stays exactly that temperature. It doesn't go up or down. Maybe I'll do another video on that itself, just to talk a little bit about that system and what I had installed. If you guys want to know, basically the mini split alone $4,000, which was at a discount. It was originally $5,000 installed. Now that includes everything, installation, everything I needed for it, except for, like I said, the additional thermostat, which was the MKZ1 or something, or M1KZ. I'll put a link down to everything below if you guys are interested in checking that stuff out. But yeah, it was basically $4,000 installed, and that was at a discounted rate. So I hope you guys enjoyed this video, found it interesting, and hope you guys learned from it if you're researching one of these units to put in your house. If you guys did find this video helpful, please share it. Please hit that thumbs up. It really helps me out with the YouTube algorithm in sharing this video. Please place a comment below. And if you guys don't know about comments, I've had a lot of people not knowing how to see the description below or how to comment. Just scroll all the way down for comments. Hit the little arrow button that's pointing down next to the video description. That'll show you, or next to the title, that'll show you the description of the video and all the links that I put below. So I hope you guys enjoyed. Please like, subscribe, share, and I will see you guys definitely on the next one if you do so. So thanks for watching, guys.